Welcome to Making Circuit Boards with Chris Dayhut. For today's video, we're going to take a look at the cutting tools that we use in this process. Cutting tools are a very important part of the isolation milling process. In fact, they're critical to the success of it. Using the wrong tools will often yield terrible results, and you'll burn up the tools very quickly, meaning that they'll get dull very quickly, causing further problems. Furthermore, when you try to continue to cut with a dull tool, it will try to rub through the substrate material. And trust me, you don't want to experience that smell. It is awful. Tools that I use in my process are specifically made for machining PCBs, circuit boards. They are made of tungsten carbide, and that makes them very hard but brittle, so they can break very easily. As a result of that, you can't really drill them with a hand drill. You're going to break a lot of the tools trying to do that. You can drill somewhat successfully using a drill press, though, manually to drill the holes, and that'll work out fine most of the time. They are ground to a very fine edge that allows them to cut very efficiently. However, these tools are also relatively small. They're short in length. The longer the tool, the easier it is for it to break. All the machining we do on circuit boards is generally shallow work anyhow. Typical circuit boards are about 1.5 millimeters thick, which in the American world, that's 1/16 of an inch. So you don't need really long tools, and typically we don't use very big tools. If you've got a big hole to mill or to put in a PCB, you will mill that hole rather than drill it to size. Now, before I get into details about these cutting tools, let's take a look at what we're doing with them so that you can appreciate the importance of having good quality drill bits. This is the bottom surface of one of the circuit boards I made recently for our Zoomtown project. These would be the pads. This is the trace. This is what's conducting the electricity from one location to another. And one of the critical aspects is this cut right here. This is what we're doing to isolate this copper from this copper. And as you can tell, that's a really small groove that we're cutting. The depth of that groove is about the thickness of 2 pieces of paper. It's a little over 0.06 of an inch deep into that substrate. The drilling of the holes, these holes here would be 0.045 diameter holes, slightly more than 1 millimeter. And these 2 holes here and here are 1/8 in diameter, or about 3 millimeters. This is a good example of why it's so important to have good tools. You're going to be working with very tiny cuts and very tiny pieces. So the detail of the tool really becomes important. Also, on the flip side of the part, we'll be engraving the letters. So if you've got a real thick tool, you can't get fine, delicate characters as seen here in this example. I buy a lot of different tools because I like to have them on hand and I don't want to go hunting for them. So I've got some bulk tools. That's in this tray. These I would have probably bought off of eBay. Somebody selling them out. Probably even a little bit dull, but they work great for me. I also buy variety kits sometimes. These are cases that I made, but the variety bits gives me options that I wouldn't normally buy tools for in oddball sizes and so forth. But I found good value in those, and as you can see, I have quite a variety of there. This whole group here are my drill bits. They go from about 4 millimeters to, missing a card here, to about 0.4 millimeters. So 0.4 millimeters to 4 millimeters, or about 15 thousandths of an inch to 155 thousandths of an inch. That's the range that I find very common for me to work with. I also buy small card variety packs as well. Two of my favorite suppliers are Think and Tinker, which goes under the Precise Bits website. I buy a lot of bits from them when I want good quality bits. And DrillBitsUnlimited.com is where I've been buying a lot of engraving bits. This particular one here suffered a catastrophic failure, so don't look at that one as being a good bit. That one just is in there, so I don't throw the case away because I got to buy more. Drill bits are used for making holes, and I've already showed you a wide variety of those. We'll take a closer look at them in a minute. And then milling cutters are used to mill away waste material or to mill shapes for the outside of your PCBs or even clearance holes or shapes inside the PCB. So the three tools: V-bits for engraving, drill bits for making holes, and then milling cutters to cut shapes either on the outside or within the outer perimeter of the circuit board. This is a close-up view of a 60-degree point engraving bit. This is very typical of what I use. It gives me good performance, good detail, and good durability. You can get finer points with smaller tip diameters or more broad points, say with a 90-degree included angle as opposed to this being a 60-degree, and the finest that I've found are 30-degree included angle. The machine that I utilize has a spindle speed capable of 24,000 RPM, and it runs pretty true. And that's critical for the success of using these engraving bits. Typically, I do perform the engraving in copper that we're using here in circuit boards at about 18,000 RPM. I also use a little bit of WD-40, just a tiny bit of it wiped on the surface of the copper to allow for slightly better finishes. Milling cutters come in two varieties: smooth cutting edge and a serrated cutting edge, often called, I think, diamond cutters might be the word they use. The serration is a better choice for performance and is much better. Even in industrial applications where machining of G10 material is performed in mass, serrated edge tools are used very commonly. This is a 0.0145 inch diameter drill bit, less than a 64th of an inch, or in the metric world, about 0.35 millimeters. These tools are at about the smallest end that I typically ever use. I work typically in that 0.25 millimeter, which would be about 30 thousandths of an inch, up to an eighth of an inch, which is the 4 millimeter range. But as you can see, the flutes are spiraled. The flute length is rather short, and they're ground to a nice sharp edge at the tip, but they're not real pointed like conventional drills. This was a 45 thousandths diameter drill, very common. And finally, I will be showing you a 1/8 inch drill bit. This is typically what I use for mounting holes, and that works out to about 3 millimeters. But again, you can see that fine edge that's ground on it, and this particular tool's been used a lot. So in reality, it's quite dull by this point, but it still works perfectly good. What you don't want to use are these common high-speed steel or cobalt drill bits that you use for all sorts of tasks around the house or in woodworking. They are not hard enough, and even with the titanium nitride coating on them, they will not hold up to continued use. They will become dull and create all kinds of problems in your manufacturing process. I mentioned earlier a couple of websites where I get my tools at. This is the one, Precise Bits, and their URL is precisebits.com. And the category that you would be looking at, if you go to Products, Application Specific Tools, Printed Circuit Boards. And that's what we're looking at here. They show an image of a circuit board. They provide a variety of different sizes, types, and shapes. They also sell the PCB material and a cutting fluid that helps with the process. And boy, you really don't need much of that. Literally a tiny drop smeared around on the circuit board face, and it definitely helps. And they have other little tools and accessories to help with your process. They also have excellent cutting data, and that's always important to know and understand. They'll tell you what RPM to run at, how fast you can cut with the tool, etc. That's always difficult to find, and it's nice when a manufacturer provides excellent information such as that. Another resource that I've used frequently is Drill Bits Unlimited. I use different tools from different manufacturers. Both of these seem to be real good manufacturers. But here you can see a V-bit very similar to the one I was showing you earlier. And then the diamond cutter, a smooth fluid end mill, a really tiny end mill, and your drill bits. To give you an idea on pricing, let's hop into, we'll get there. Here we go, an engraving bit of this type is going to be about $15. And I have to emphasize the importance of buying a quality engraving bit. A lot of the ones off of AliExpress or even Amazon that are engraving bits in their V-shaped, often single flute, etc., those aren't necessarily designed to cut well in copper. Oddly, copper is a very difficult material to machine because it is so soft, it would rather move out of the way than cut. So take it from my advice of 45 years in manufacturing and metal cutting and machining. Copper is a tough material to machine precisely with minimal burring and with minimal tool breakage. So spend your money wisely on your engraving bits, drill bits, and the milling cutters. You've got a lot more latitude into the requirements for them being so perfect and high-end. But always watch for good quality. That's what you're after in cutting tools. As for speeds and feeds and so forth, as I mentioned, you can get that data, the cutting data, from the manufacturer websites. Also, if you were paying attention in the previous video where I was converting the design layout into a CNC program, I showed you very practical examples within the software that I use to generate the CNC program. Those are very reliable numbers. They worked well for me. And luckily, in our case, there's a lot of latitude in that speed and feed recommendation. Just don't try to go too fast. With that, I think we'll wrap up this video at this time. In the next episode, we're going to start machining our first PCB, and I'll be showing you the operation, very specifically, isolation milling. With that, we'll wrap up this video. Thanks for watching, and I look forward to seeing you in the next video. And if you could be so kind, I would greatly appreciate it if you could give me a thumbs up, share the video with your friends or anybody, and if possible, subscribe. It costs you nothing. Thanks again.